Hi guys, this is Fazan and welcome to this session. This session is about competitive programming for beginners, part 4. So before we start, can you guys quickly give me a confirmation that you guys can hear me properly? Is there any noise that you are hearing or any echo so that we can rectify it right now? And in the meanwhile, while we wait for others to join, Great Learning has come up with a Great Learning Academy initiative wherein we have 100 plus courses available for free, and after the completion of that course you will also get a certification that you can put on LinkedIn or in your resume, also at the projects, right? So cool, I can see that. Okay, cool guys, cool. Okay, great. So now let's get started. So today we are going to talk about arrays, and in the previous part, right, in the previous part we talked about arrays and stacks. Can you guys quickly tell me how to identify when to use a stack in arrays quickly? What I gave you the trick, right? When you guys can quickly identify, okay, in this question we are going to use stack to solve this problem. Quickly guys, just give me a yes or no so that I know that you guys are following along. Anyone? Abhishek, Sudarshan, Dipanshu, Afrin, Akash, any one of you guys can quickly tell me is when we have two loops. Okay, great Abhishek, great. And they are dependent and the inner loop is dependent on the outer loop, right? Great Abhishek. So now let's see how to identify when we can use, before we start that thing, let me just complete this question, which was the last question that we skipped in the previous session. Okay, great. So now in this question, as you can see, we have to find the maximum rectangular area in a histogram. Okay, so histogram is not given to you, okay guys. So there is only one thing that is given to you, is an array, and these arrays represent the heights, okay, or the histogram that is shown on your screen, right? So these are arrays. Can anyone tell me, can there be a negative value in a histogram? Just a question, just a simple question, yes or no. Can we build a histogram having negative values? Okay, so we can, but we won't, because then we have to do some labeling to that. Okay, for now, okay, yes, for now we can assume that we cannot build a histogram based on yes, great Sudarshan, great. So now for now we can say that the histogram cannot have any negative values. So you will always be great Abhishek, yeah, never seen, yeah. So we can do it, but we can do it, yes, but we won't because then we have to do some kind of labeling to it. Okay, so that is out of the question. So in the given question we have been explicitly told that this array will be a non-negative array. Okay, now if you can see, these are all heights. Okay, now if you see, now we have to find the rectangular area. So if you see the histogram 6, then we have 2, then these are all heights. Okay, now if you observe carefully, can I expand 6 either on the left side or on the right side to make it a rectangle for 6? Quickly, can, yes, no, maybe. Can I expand 6 either on the left side or either on the right side of 6? That's the first building. Will you use Python? No, I'm not giving you any specific, I'm not going to use any specific language here, but yes, for now we are using Java. You can easily implement it on your in Python or JavaScript, anything. No, you can't, Sudarshan Sarvan. Okay, so right now, okay, so right now if you observe this carefully, we cannot expand it either on the left side or either on the right side. Okay, why? Because to expand it, the height should be either less than the 6 or equal to 6. Okay, now let me show you this diagram first. Okay, great. Let's leave it. Okay, now if you observe 4, for 4, the number 4, the height, that is 4, right? We can expand it on the left side as well and on the right side as well, because the fourth left side is 5. So we can expand the rectangle, we can expand this 4 on the left side and we can expand this 4 on the right side as well, right? Okay, so now on the left side of let's suppose now we are talking about 2. So 2, if you can observe, we can easily expand it until we see the height that is what? So it should be either less than, or it should be greater than or equal to 2. So 2, if you see the right hand side of 2, we have 5, we have 4, we have 5. So we can easily expand it until that point on the right hand side. But on the left hand side, we can only expand it on the 6 side. 6, okay? So now if you see, we have already done this type of problem, right guys? Now what we are going to use here, we are going to use something that I already taught you guys. What? 2 things that we will be focusing on near the next smallest number on the right side and the next smallest on the left side. Okay, now let's see. So if you observe carefully, what is the next smallest on the right hand side of this 6? That is 2. Okay, so what we are going to store in our stack? Okay, so now what we are going to, yes, time complexity is big of n, right? Yes, Thamzira. Okay, now if you observe carefully, now if you see the next smallest on the right hand side of 6 is 2, right guys? You see, and what I have stored in the stack, right? We know, I know that I can use stack in it, because inner loop will be dependent. That thing we are not covering in this, the naive approach. We are going to straight away into the main function. Okay, now if you see what I'm storing in the index in the stack here are the indexes. Okay, and when we talk about on the right hand side, we reverse that stack, right? We reverse the elements, right? We will store it in some kind of an array, then we will reverse it. We know that I have already taught you guys, right? So okay, so now what we do, we will cover. Okay, so for 2, for 6 it is 2. For 2, what is the smallest? It is 5. So if you can see that here 1 is having the smallest, the 2 is having the smallest, 1, the element is 1, and the index is 5. So similarly, we are going to store for all these indexes. Okay, so for all these elements from the right hand side, we are going to store the indexes. Okay, similarly, we will do the same thing for the left hand side. Any of you have any confusion regarding this thing that I have shown you guys regarding this thing? This has been already covered, right guys? So quickly give me a confirmation, yes or no. Can you, I mean to say the the 4 things that I have written in the 4 lines in this slide, the first 4 lines, are these lines clear or not? Quickly guys, yes, no, maybe. Abhishek, Thamzida, Sahil, Sarwan, Nisha, any one of you guys? Just quickly write a yes or no. Okay, Gaurav, I will repeat it. Okay. So if you see, if you see the first height, that is the 6, the first element. The first element is 6, right? If I expand it, or if I want to check what is the smallest element on its right hand side, what it will be? The next smallest, not the immediate smallest, not traversing till the end of the array or till the end of these heights, but traversing only to the next element. Okay, so if you observe carefully, what is the next smallest of 6 on the right hand side? Is it 2? Is it 2 guys? Quickly, yes, no, is it 2? Quickly guys, I'm waiting for your answer. So similarly, if you see for 2 it is 1, right, on the right hand side. For 5 it is 4. For another for the 4 it is 1, and for 5 it is again 1, and for 6 there is no element on the right hand side, so it is for now let's suppose it is -1. Okay, got it guys? Great. Now if now I found out that until what point I will be able to expand this thing. Okay, for 6 I will be able to expand it something around, I mean to say the 2, but I will stop on the same thing, right? How to get these code forces? Tech for you, what are you trying to say? how to get started at core force. Okay, start with basic questions. Start with basic question. So we can also use recursion for the max of a and max of a or of a. Yes, you can, but recursion will recursion will I mean to say the time complexity will be increased. Though you are using recursion internally, the stack has been used, but you will be increasing your time complexity. This problem will be solved in big O of n time. That is the time complexity it will take is order of n. When we talk about great learning, how to get started. Okay, so you can get started on cone force tech. Just start with, I mean to say, maybe in the next session or something, that is after this session, maybe I will do some of the courses, some of the coding questions based on code forces. Okay, will that work for you? Okay, cool guys. Now I found out the right hand side of all these things, the smallest. Now similarly, I will show you how to calculate the, I mean to say, how I will be able to calculate the expansion thing. Similarly, if I did something on the left hand side, what is the smallest element on the right hand side of the 6? That is the first 6. No one, right? -1. And for 2, what is the next smallest? Nothing. -1. For 5, it is 2. For 4, it is again 2. For 5, it is 4. For 1, it is nothing. And for 6, it is 1. Okay. Now that I have calculated all these things, what I will be storing in my stack is this thing, right? The indexes of those. If you see, the index of 2 is 1, right guys? The index of 4 is, I mean to say, for 6 it is 1, and for 1, for the index of 1 is 5. So I will be storing these indexes in my stack, right? So now once I have stored for both these arrays, or both these left hands, finding the left hand smaller element on the right hand side and finding the smaller element on the right hand side. Now that I have stored all these elements, now what I will be doing, I will calculate the length. Okay, let's suppose, now let's talk about 6. What will be the maximum rectangular area of 6? I mean to say, how can we make a rectangle, and which is let's forget about maximum right now. What is the rectangular area that will be covered by 6? Okay, tech. So it will be, I mean to say, it will be something that is only, it will contain only 6, right guys? So if you can observe carefully, now observe carefully this thing. Okay, let's skip that one part for now. I will show you the thing, another thing. So for 4, what will be the maximum area covered by this rectangular? How can I expand this 4 on the left hand side? It is up to 5, right? And on the left hand side it is 5, and on the right hand side it is 5. So this will be the rectangular area I will get from index 2 to 4, right guys? And how to calculate the area? It is length into breadth. Now how will I calculate the length? It will be the index 4. If I subtract it from 2, the index of 4 is what? The index on the right hand side of the 5 is 4, and for the another pillar that is on the left hand side it is 2. Now if I pick these indexes, I have already calculated these indexes, right? The 4 for 4 it is 5, the index 5, and for 1, for this 4, that is the index on the right hand side it is 5, and for 4 it is 1. So now how I calculate this length? If I subtract 5 minus 1, that is 4, and minus 1 because indexing starts from 0. So I will be able to calculate this 3, the length 3. And if I multiply it with the height of that current element that I am on, that is 4, that 4 into 3 will be 12. Right guys? So this will be the area of this 4. I mean to say, I can expand it on the right hand side, I can expand it on the left hand side. Okay? Now if you see carefully, I have used the same approach, okay? And now then I will be doing it for all the other elements as well. Similarly, on the right hand side, I will pick up the index on the right, on that particular, I mean to say how many times or how much I can expand it on the left hand side, or how much I can expand it on the right hand side. Okay guys? So this is simple, fairly simple, right? Now there is one thing that it will, I mean to say, it will give you an error. Can any one of you can rectify it? Before you can rectify it, is the thing that I was talking about, is this clear to you guys? That we have to go on the right hand side and put those indexes in the array, okay? Put those indexes in the stack. Similarly for the left hand side and for the right hand side, store these indexes in the stack, then pick up these indexes, subtract -1 from it. I mean to say right hand side minus left hand side. This will be the left array and the right array. The first one will be the right array, the second one will be the wherein we are storing the indexes, right? The right array and the left array, and then we will be subtracting -1 in order to calculate the length. Then to find the area, we will just multiply it with the current element, that is ARR of I. Now similarly, when I do it for the all, I will calculate the maximum height. Now if you observe carefully, now the right hand side, now let's talk about the right hand side. If you observe carefully, what is the minimum element that is on the right hand side of 1? Is it -1 or is it 7? Because 7 will also be a hypothetical index which is 0. Okay guys, in order to calculate it, we will put this hypothetical index on it so that it will give us the correct output. Okay, now if you observe earlier case, let's talk about the earlier case. What should be the, how much I can expand this one? I can expand this one up to the index 0 on the left hand side and up to the index 6, that is index 6 on the right hand side, right guys? So this will be, the length of this will be something that is 6 minus 0 minus 1, that is 5. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, it should be 7, the area should be 7. But when I calculate this thing from these indexes, I won't be getting 7. Now let's see. For 1, I have written -1, and for on the left hand side, I have written again -1. So for 1, I have written -1 on the left hand side and -1 on the right hand side, right guys? Now if I calculate this thing, it will be what? -1 minus minus will be +1, -1 and +1 will be cancelled, and it will be -1. So the area will be negative. Is that possible? Is that even possible? Can I get an area of value? Can I get an area whose value is negative? No, right? So this is the problem that we are having right now. Now if I put a hypothetical index over it, right, so that I can get from the right hand side there will be index 7, and for on the right hand side it will be 7, and on the left hand side it will be -1. Now let's try to calculate it. Now if you see, now for 1 I will be getting 7, and for 1 on the right hand side I will be getting what? 7, that is the hypothetical index, right? For 1 it will be 7 because 7 is 0, that is less than 1, right? And similarly, if I do it on the left hand side, right, I will be getting -1, obviously 0 and then the index -1. Now if I calculate this thing, now what will be the value on the right hand side? It will be 7, minus will be +1, it will be 8, then -1, it will be 7, then multiply it with the array element, that is 1 into 7. Now I'm getting this 7 as the area. Okay, now you see the significance and what was the problem with this code, right guys? So on the right hand side, if there is nothing less than the element, then put a 0 on it. Okay, so it will be 0. Obviously there will be a hypothetical height at index 7, that is 0, right, which is less than 1, right guys? So that's the thing, that how we can avoid those error conditions or how we can skip from those. Okay guys, sir, I want to Python language detail like this. Okay, Sarthak, we will work on it. Okay, now guys, quickly tell me, is this thing clear? Is this thing clear to you guys? This was the previous question, so quickly just write a yes or no so that we can just move ahead with this thing. So now to calculate, okay, great Abhishek. Now if you see, we will be calculating the we will be storing the indexes in the first array in order of n time, right? And similarly for the next, I will be storing it in the order of n time, and to calculate the maximum on each element, I will be traversing through all the elements, that will be again order of n time, right? So now it will be O of n plus O of n plus O of n. So it will be 3n, but the 3 is constant, so we can neglect it, right guys? So now the overall complexity of this problem is big O of 1. Now if some of you guys were thinking about recursion, but the recursion will take much more time, right guys? Great. Now is the trick. Now we have covered the stacks, how to identify those things, right? So that thing has been covered. Now arrays is the most important topic when we talk about competitive programming, because there are a lot of questions that can be made with the help of arrays. Now we will see. I'm trying to follow. Just joined the inciting session for the first time. Okay, no problem, guys, no problem. Now, what we will talk about is completely individual topic. What we have learned so far. So, once the session is over, you guys can just revise, go through it. Okay, guys. Now, how to identify when we can use a heap on an array. So, right now, I will show you a trick how to identify those things. Okay, you will see a question. Okay, you will be thinking, okay, now I can use heap on it. It's definitely sure that I can use heap on it. I told you guys how to identify when to use stack on an array, right? Now I will show you a trick then how you can identify when to use heap on an array. Okay, now arrays and heaps. Up to this point was arrays and stacks. Now arrays and heap. Now look at this question, guys. You need to find the kth largest element. You have been given an array 625417, right? And then there is a k, that is which largest element. Is it third? Is it second? Is it first? So this k represents that number. Okay. Now if you observe, which is the third largest element? Is it 7? No, it's the first. Is it 6? No, it is second. Now is it 5? Yes, it is the third largest element, right, guys? Now if you see the second example, now we will get more clarity. So if you see, the third largest is it 70? No. 50? No. 16? Yes, it is the third largest element. Now you need to give me that element. Okay, the third largest element, or this k is, this is arbitrary value, right? So it can be anything. Now quickly, guys, tell me what is the approach that you guys are thinking. Some of you guys will be thinking of sorting it, right, guys? You will be thinking, oh, I will sort it and I will get the index, right? That is the first approach, the naive approach, right? So if you sort this array, you will get 1, 2, 3, 4, 5, 6, 7, and then what you will do will be, okay, so there is a misprint. Okay, what you will do after that, you will do array, the length of the array. Okay, guys, the length of the array minus k. It shouldn't be k minus 1, it should be length of the array minus 1. So length of the array is 1. There are 6 elements, that is, there are 6 elements minus k. Okay, that is 6 minus 3. It will be what? 3. So the element at index 3 will be our output, right, guys? So now the output isn't 4, it should be 5. Okay, so great. So now we have seen the naive approach. Now the sorting time, okay, here is it. Okay, great. So now if you see what I will do, I will do array.length minus k is the element and the output should be 5. Okay, guys. Now if you observe carefully, what is the time complexity that I am taking? The time complexity of sorting any array is n log n, right, guys? If you talk about Java, and internally it uses quick sort, right? In some cases it will use merge sort, but both of these sorts, the time complexity, when we talk about the merge time complexity, will be order of n log n. Now can we do better? Now we can use heaps. How we can use heap? Now let's think about it. We will use a min heap. Okay, I'm not getting into details how you can build a min heap. Now for now we will use the Java classes, that is a collection framework, right, guys, wherein we will use priority queue, which internally builds the default version of building. When I'm using priority queue, internally it builds min heap. Okay, now what do you mean by min heap? The minimum element will be at the top. No matter what, if they won't be sorted, but it was sure that the minimum element will be at the top. Apart from that, there won't be any sorting or anything that is symmetric, or you will get if you have if you have the first element as minimum element, then there is the second element will be again, it will be the next minimum. No, that is not the case. Only that one thing is sure, the minimum element will be at the top. Now if I have built the min heap, right, now I will be getting the first minimum. Now if I remove some elements from it, right, I need to find the third largest. So if I remove some elements from it, okay, guys, now what will be the output that I will be getting after removing 3 elements? Let's suppose I will remove 3 elements. After that, I will be getting this 5, right, guys? So this is the approach that I am using. So now if you see, I have done nothing. I built a heap, right, with the help of priority queue, okay, which is of length k. That is, it will contain only that many elements which I require. Okay, for example, if you want to find k is 3, then the size of this priority queue will be 3. If k is 4, the size will be 4. Okay, similarly and so on. Okay, now I have built this priority queue of size, or the length of this priority queue is 3. Now what I did, I just inserted, or I mean to say, I inserted for the first element, that is, there's the first element at 6. I inserted it in the heap. Okay, now I checked, is my heap size greater than k? Obviously it is not. There is only one element in the heap, right guys? And k is 3, so 1 is not greater than k. Now I won't be popping I won't be popping anything, right? I won't be removing anything from the heap, right? Now comes, after 6 comes 2. Again it will be inserted. Now comes 3. Okay, now now comes 5. The 5 will be inserted. Now the heap size is 3, and it is not greater than, but it is equal to. So I will remove this element, okay? Because at most I will be keeping, I will remove something. Now what is the element that will be removed? We will see. So now once I remove this element from the heap, then there will be only 2 elements. So at most I will keep 3 elements in the heap. Okay, so now I will be removing the minimum element, that is 2. 2 will be removed. Okay, now let's see. Then I will do the process again. Then 4 will come. Then 4 is I mean to say, it is not now the minimum, next minimum in this window is what? 4. So 4 will be removed. Now we will be having 6, 5 in the heap, and 4 will be removed. Now 1 comes. Now 1 is the minimum, it will be removed. So in the heap we will be having 6, 5. Okay, now once again when the 7 comes, okay, then what? It will remove this 4th element. Okay, now once I remove this element, okay, so after that I will stop. Okay, and I will get this element. Now if you observe carefully, then there is some problem in it. Okay, now quickly identify what is the problem in it. Now I will be removing another element, then another element, then another element. Then how I will be able to track those things? 6, 7, 6, 5. What is the 7, 6, 5? It should be 5, 6, 7, right, Abhishek? So now I am traversing till the end, and I am adding each element in the stack. I mean to say, in the queue. Quickly, Abhishek, quickly, just give me an answer. What is the problem in this? Is there any problem, or is this code fine? Quickly guys, just give me a yes or no. You guys can also sort this thing, but sorting is not the right approach, so we are using heap. So now you guys quickly, Abhishek, anyone, Afreen, Vishal, Anchal, and who else is chatting? Okay, okay, Sohani, any one of you guys can tell me what is the problem in this code. Okay, okay, Kavya says yes. Okay, Kavya thinks this is right. Okay guys, so there is no problem in this code. This code is fine. Okay, so now at the end I will be removing the last element, which will as Abhishek said, it won't be 7. These 3 elements will be in the heap, but the minimum element will be at the top. So after that, once we have traversed all the array, so after that we will just remove the first element. Okay, now what is the time complexity? Any one of you guys can tell me what is the time complexity? Space complexity, we know that order of k, right? How many elements we are storing? We are at most storing 3 elements in the heap, no matter what the size of the array is. So it always depends on the. Okay, Shiva says please explain. So Shiva, you understood that at most 3 elements will be in the heap, right? So once we have encountered the last element, right? At that time, what will be the element, or what will be the element that we are? It says order of 1. So no, the space complexity won't be n. or it will be order of k, the space complexity. And when we talk about time complexity, we are traversing each element, so it will be n into what? Now adding an element and removing the element. Okay, so in heap, or when we talk about priority queue, the time complexity will be log n. So we are adding and removing the elements at most n time. Okay, so inserting, the order will be log n. Okay, now the time complexity of this will be order of log n, or in this case order of log k, which is less than the earlier. In the earlier case, we were having time complexity of n log n, right guys? Now in this case, we will be having time complexity of n into log k, because at most we are removing or we are adding what we are adding. Okay, great. So now we are removing at most the order of the k elements. Okay, now let's see the other question. Now you have been given nearly sorted array. Okay, so in this we have been given a nearly sorted array. What do you mean by nearly sorted? If and there will be it is also known as k sorted arrays. Okay, so if you observe carefully, it is 2, 5, 4, 1, 7. The k value is 3. Okay, now what does this mean? So this means that either this 2 will be at its own position, or it will be either on the right hand side, it will be present on the right hand side, or it will be present in the 3 indexes on the right hand side, or it will be present in the 3 indexes on the left hand side. You see carefully the input, the second output. If you observe this 16, the original position should be 3 places on the right hand side. Okay, the original position of 16 should be when I add it should be at 0, 1, 2, 3 indexes. So at most it will go on the 4. So the original position is this 16 of this 16 is 3, and of this 10, you see on the left hand side the original position is at index 2, right? So at most it can go on 3, right? If k is 3, so it can shift to 3 places to find its original position on the right hand side or on the left hand side. Is this question clear to you guys, or do you want me to repeat? So think about it. Till then I will just explain Preetham this question again. So Preetham says please explain. So now what we did, we are adding elements in the stack, in the heap, right guys? So one by one I will be adding this thing. So when I inserted something, when I inserted 3 elements in the stack, okay, so indexing starts from what? 0, 1, 2. So 2 after 3 elements, right? There will be 3 elements in the stack, right? So in the heap, right, it will be 6, 2 and 5. Okay guys, okay Preetham. So now the heap size is 3. Now it will skip this thing, right? Because k is not less than. Now once again, when I add the next element, okay, in the heap, it will check, is this element greater than the k? Yes it is. So it will remove the minimum element. It removed the minimum element. Now the heap size is 3. Again it will go and check, is this 1? I will insert 1. Again it will check, is the heap size greater than 3? Okay, got it. Okay, great. So now let's see this question. Okay, yeah. So now is this question clear? Abhishek, Sumant, Shivi, Afreen, Manpreet, is this question clear? The k sorted array. At most it can shift to 3 places on its right to find its original position, or it can shift towards left at most 3 positions to find its original place in the array. It is sorted, but it is sorted in a tricky way, right? It can either go on the left hand side to find its original position, or on the right hand side. Quickly guys, now you guys will be thinking, okay, I will sort this. Why would I won't be using anything. I will sort this array. Okay, done. But did he use this k factor anywhere? No. Again the time complexity will be order of n log n, right, for sorting this thing. But we never use this k. Is this k useless? No, right? So how to use this k? Now again we will be using priority queue. Now if you observe carefully, the same thing that we did earlier. Okay, now if I maintain a stack or if I maintain a queue, not a stack, if I maintain a priority, if I maintain a heap. Now, if I meant, yes, understood the question. Okay, great, Abhishek, great. So now you will be thinking of sorting it, but sorting you will be using this k factor, right? This k will be number of elements that I will be storing in the heap. Okay, so if I stored the 3 elements in the heap, okay, now listen to me carefully. Okay, yeah, priority queue, great. So now if I somehow, let's suppose I stored 3 elements in the heap. Okay, now if I remove the first element, what will be its original position? Will it be at 0 index? Yes or no? Quickly, guys. Will it be at this? If I remove something from it, if I have stored 3 elements somehow, let's suppose I have stored 3 elements. Yes, you can, but why would you use it? I will show you when to use hash map and when not to use hash map. But not in this session. Obviously, I will tell you at the end. Okay, so this session is all about arrays and queues. I mean to say arrays and heaps. Okay, so now if you guys observe, when I put 3 elements in the in my heap, then I will remove the minimum element. Obviously, that minimum element will be at 0th index, right, guys? Now look at this look at this solution. Now what I did, first I stored 3 elements in the heap, right, guys? I added first 3 elements in the heap plus the 1, right, including this one, right? This I mean to say, if I am talking about the original position of 2, it is at position 2nd, but it can be at position 3, it can be at position, right, guys? Are you getting me? If any one of you having any confusion, so now listen to me carefully. Okay, now let's suppose look at the second example. Okay, first one is much simpler, wherein we won't be able to cover so many, I mean to say, the things that I want you to analyze. Okay, so if you observe carefully, is it possible to do competitive programming with Python in future? Yes, it is. But usually most of the coding, that is competitive programming, is done using either Java or C++. Okay, now observe carefully, guys. So if you see 16, 2, 50 and 4, okay, if I somehow stored all these elements in a heap, okay, 15 is the second example, 16, 2, 50 and 4, if I somehow stored all these values in a heap, and when I remove the first element, what will be it? It will be the minimum and it will be present at index 0, right, guys? So that's what I'm doing here. I first added all those elements in the heap, the 4 element. That is why I have written k plus 1. K is 3, then it becomes 4. So 0, 1, 2, 3. Okay, so 4 elements will be stored in the heap. Now what I'm doing, I'm using this int idx pointer as the first index. Okay, so earlier at the start it will be at index 0, right, guys? So then what I'm doing, I am just popping out the first element, that is removing the first element and adding that element. Okay, so once I have removed it, then I added this element in the array index plus plus. Okay, this is post increment. So first it will be at 0 and then we will increment in the next step. Okay, so at ARR of 0, that is the first element in the array, so we will just remove this element and enter it in the array index, that is the first index. First element will be at 0th index. Then what I will do, again I need that proper size of 4, the window size of 4. Again I will add one more element from the array. Great, you got it, right, guys? Are you getting me? Quickly, Preetham, Tharindu, Abhishek, Sumant. Quickly, guys, quickly. Yes, no, this is very easy. Just try to analyze. So first I will be adding 4 elements. Then I will be removing one element, adding that element in the array index, that is the first index of the element, that is the first element in the array. So after that I will just increment the pointer, and then I will add another element because the window size should remain under that frame, right? It should be 4 elements that I am storing again and again. So once, if you see, the next loop is starting from k plus 1, right, guys? Great. So once I have started, I will reach at the end. So at the end there will be some elements that won't be removed, right? The 4 elements won't be removed, right, guys? because I will reach at the end. So once I reached at the end, so only first element will be removed. So at last we will be having 4 elements that are already present in the heap. Then this while loop is used just to remove all those elements, because every time when I remove this, when I use this remove function or poll function in heap, it will remove the minimum. I will keep adding it to that new array, right? The index 0 at that position, right? And incrementing it. So I have sorted it, but not sorted it. And again, I have reduced the time complexity using min heap. I have implemented it. I have used extra space, but that's not the point. I have removed the space time complexity, right guys? Great. So now this was the second approach. Now let's see the third problem, and this is something that was asked in Amazon, right? And this problem is a hard problem. Now let's try to analyze this. Okay, so you have been given this array. Okay, so is the earlier question clear, guys? Just quickly give me a yes or no. You got the point, right guys? I'm just here to give you intuition how to think over the problem, right? We have seen, okay, so we have seen arrays and stacks, right? Now we are seeing arrays and queues, I mean to say heaps. So you need to analyze it. There are a lot of questions that I won't be able to cover these questions. Okay, you have to analyze this thing, so that if you analyze it properly, you can do a 90, maybe 100 questions on the same thing. Okay, so that's not the point of doing something. It is trying to analyze this thing. Okay, great. So you understood the first problem. Okay, now this was something that was asked in Amazon. Okay, and you see the point here is clear, that now you need to analyze it. Now you have understood something. Now let's try to analyze this problem. So here you have been given this array. Okay, if we would have used stack in the last problem. So again Gaurav, the point here is not using something. The point here is trying to identify what to use. This is not the point. You can use, obviously, you can use recursion, you can use stack, you can use another array. That's not the point. The point is, when you see a question, okay, this is the question, I can do this thing to it. Okay, now I will use heap in it. Okay, that's a hit and trial method. You are saying that I can use stack, obviously you can use stack. So that's a hit and trial method. Now herein, obviously you will need to think, okay, can I use stack, that will take time. If that's not the case, if you see something and you know, okay, I'm going to use heap, then one thing is clear. Okay, that one thing, that the time that you will utilize in thinking, okay, can I use stack or not. Here I'm telling you can use heap. Okay, and I'm telling you how to identify it. I will tell you. Okay, Gora, okay, great. Now let's see this problem. Now we have to minimize the cost of connecting ropes. What do you mean by this thing? If you see, this array is given 2, 5, 4, 1, 7. The output should be 40. And now how we will get this output? Okay, now let's see. If you see, this was the array that was given to us. Now I have to minimize this cost. Okay, now the first thing that you will get, okay, now what is this cost? What do you mean by this cost? This cost means if you have taken any two, this is the length. Okay, this is the length of this 2 represents 2 units of length of the rope. Okay, now you have to pick any of these and connect them, so that you can, when you are connecting them, you have to reduce the cost. And what is the cost? Okay, now let's suppose you have picked 2 and you picked 5. Then you connected it. It gives you the output of 7. Okay, now 7 is the cost. Okay, now again you will insert it in back, because now you will be connecting something to it. Okay, now you have 7. Now you connected 4 to it. So the overall cost of this will be 11. So 7 plus 11. That is how you do it. That is the problem. Okay, this is the problem. This is not the solution. This is the problem. And I'm giving you with reference to some kind of a intuitive approach. Okay, so now you have 11. Okay, 7 plus 4 is 11. Now 11 plus 1 is 12. Now this 12 is the cost. This will be added to that thing. 7 plus 11 plus 12. Now again, now this 12 will be now 12 is one rope, and you will have second rope is 7. That is only rope that is left. 7 plus 12 is 19. That will be the cost. So all these costs. Okay, I will explain. Okay, I will explain again. So all these costs. Okay, now these will add up, and this will give you the total cost, that is 40. right? So okay, do you want me to repeat again? Is it still unclear, quickly, I'm waiting. Or is anyone of okay, sir, do any one of you want me to repeat this question? So you just have to pick okay. So now what clear, okay, Vinay says clear. Neha says yes, sir. Do you want me can't get the question? Okay. So the question is that you have to minimize the cost. And what does the cost mean? If you pick any of these lengths, right? These two, the array elements, that is 2, 5, 4, 1, 7. These are lengths, okay? If you pick any of the two lengths and you add them up, okay? Now you have to add this, you have to make a complete rope, okay? Complete one rope. But you have to, you have 2 units, you have to add them with 5 units, okay? Now you have to add all of these elements, okay? And while adding those elements, the cost associated with it is something in this way, okay? So for example, you have picked a 2 unit rope, okay? Then you picked a 5 unit rope, okay? Now you added them, okay? You combined them together so that you get a single rope, right? So now you have combined them, you get a rope of 7 length. Now this is the cost. This 7 is the cost. You will put it somewhere in some variable, okay? This is the cost, that's 7, okay? Now this 7 will be again present in that array, but in place of 2 and 5 you will write 7, okay? That's it. Now 7, 4, 1, 7 is the ropes that you have. Now you will pick 7 plus 4. It will give you 11. This is the cost. Again you will put it in, add this 11 to that variable which we earlier used, okay? 7 plus 11, so that we will get the total cost. Again you will put it in back in the array. Now what will be the elements present in the array? It will be 11, 1 and 7. Now 11 plus 2, this will be the cost. This 12 will be added to this thing, okay? Let me show you this thing, okay? So now you have picked, okay. So now once you have picked the last element, sir, please organize web design per live session. Okay, Shivi. So now at the end, what was the output? It was 2 plus 5, that was 7, okay? Just write it somewhere, okay? 2 plus 5, it will give you 7, that's the cost, okay? And 7 will be again one single rope. Now 7 plus 4 will give you 11. So 7 plus 11 is what? 7 plus 11 is 18 is the cost, okay? Now 11 plus 1 is 12. Now 18 plus 12 is 30, okay? That's the total cost. And 12 plus 7 is 19. So now if you see what we got as output while connecting this in a naive approach, we got the output as 49. But is that minimum? No. Now we need to find how we can connect these rope in order to get the minimum cost. Got it, guys? Now I have explained it in a naive fashion. Now you have to connect these ropes in order to get the minimum in order to get the minimum cost, right? So now if you see, if some of you guys will be thinking, okay, again I will sort this thing and add them up, right guys? But that's not the case. For example, if I have sorted this array, so we will get 1, 2, and then we will get 4, and then we will get 5, and then we will get 7 when we sort it. Now we picked up first 2 elements, that is 1 and 2. It will give me 3. So 3 will be the rope and the cost is 3, right guys? And that will be again put it back into the array. So again I will sort it, because maybe adding it at the end, I will sort it again. So please use sketch option and explain the scenario. Okay, we will do it next time, okay, hopefully. Okay, Vinay. Now what you see, we got the 3, and then we put it back in the array, and then we again sort it, right? Because adding an element we will add it at the end. It's not obvious that okay, understood the question. Great. So now you will sort it. Okay, you will be thinking, okay, I will sort it and pick the first 2 elements and again sort them. Okay, now that's the case what I'm doing here. So again 3, I will pick 3 and 4. because while sorting this 3 5 4 7 will give me 3 4 7 3 4 5 7. Now again I will pick the first two elements. Okay, okay, Gaurav says something. Okay, Gaurav, on to me in here. Okay, so now what we have 5 and 7. We pick those two elements, and 12, and we got the 40. So now this sorting again and again, right? Sir, ये Amazon में आया हुआ है. Yes, it has. It was there in the Amazon. Okay, and the mean to say the complexity of this problem is medium, or sometimes it gets in some different websites. I mean to say geeks or gigs somewhere, they will have to choose two elements. And now that's the thing, Shivi. That's the thing. How to choose these elements? Okay. Now, yeah. It is 41. Yeah, Sam. It is 41. Yeah. Some 22 plus 19 is 41. Yes, that is written 40. It is 41. Okay. Now, if you see, now the whole problem is understanding how to choose these elements. Now we can sort this. Obviously, we can do it, but it will take again and again. We have to sort again. So once we add it, again we put the element in the array. Again we need to sort that. Again we need to sort that. So that is much more time complexity, much more time consuming. Now, if you see the one more approach of using this problem is, if we do sorting, that's the case, right? Now, if somehow I have these elements present in a heap, all of these, right? Now, if I pick the minimum two elements, okay, right? I picked minimum two elements, okay. So let's suppose in this case it will give you 41 again. But if you take it another example, some other example, then you will be able to find the how to do it, okay. So now let's see the problem of I mean to say how to analyze it and how to pick these two elements, okay. Now, if I pick the first two elements, okay, from the heap, right? I put all the elements in the heap. Now I removed first two elements, okay, A and B. Let's suppose I removed the minimum two elements in this array are 2 and 1. So 2 and 1 will give me 3, right guys? So that's the minimum cost. Again I will push it back into the heap, right? Because I need that thing, right? Can you hear me, guys? This approach is very easy to understand. Okay, yes, obviously. So there is again one thing missing, that is I haven't added back this temp into the heap, because again I have to remove the two elements and then including that previous one, okay. So again you have to, in the while loop, you again have to add that element, okay, right guys? Can we use STL interviews? Yes, you can. So now, is this problem understood? It is easy, right guys? There is nothing new to this problem. You just have to pick the first two elements, add them up, put them in the I mean to say the maximum cost or the minimum cost variable, add them up, and again when you remove this thing, you just have to insert it back into the queue, okay. Final n log n सर वैसे हमेशा हायर वैल्यूज के लिए एनालिसिस करते हैं. Yes. So now you see, this is not okay. Great. Now if you see, wherever you think you can use sorting, now this is a trick. Wherever you think you can use sorting, or you think, okay, I can sort this, I will get the answer, use heaps. You have to use heaps, and that is 100% for sure. Whenever you think of, I mean to say, solving any problem, and you think or you have any kind of idea, okay, I might be using some kind of a sorting here, okay, at that time it is for sure you can use heap, okay guys, is it clear? Is the trick clear to you? Wherever you think you can sort this thing, use heaps. It will reduce your time complexity. Though we will see, this is just a starting, okay. Now we are trying to connect the dots. This is just the starting. Can we do better than this? Yes, obviously, in some cases, okay. So therein we will see how to use trees with this thing, okay. Great. Therein we will see how to use trees, how to use BSTs, how to use different data structures. Those we haven't covered it yet. So whatever we have learned or whatever we have studied until this point, we are using only those things. Okay. Sorting में क्या mostly होता है? Yes, sorting. Whenever you think you can sort this thing, okay, use heaps. Heap will also give you the answer. Okay. Now, in the next lecture, what we will do, we will connect three things: arrays, heaps, and hash maps. Hash maps are the most important thing in CP. And anything when I will show you how to identify this thing, how to use hash maps. What is the trick? Again, you saw the trick in arrays, you saw the trick in stacks, you saw the trick in heaps. In the next lecture, we will see how to identify. Okay, I should use hash map or hashing. Okay, so in the next lecture, we will cover those things and we will cover this same thing. Okay, arrays will be used, heaps will be used, and hash maps will be used, all in same problem. Okay. Yes, you can. Anywhere you think you can. Hash map question was also there. Exactly. These are very, very. Yeah, sir. Randomized merge sort also has same time complexity. I told you, Gaurav. I told you. This is not about what you can use. You should know what to use. Okay. You can use anything, any damn thing in this. You can use either you can use tag, you can use that thing, you can use these things, but you need to identify. Okay, it's all about reducing your time or thinking over a problem. Okay. Now if I told you, I told you in advance. Okay, Gaurav, you will be getting this problem in your question. You will be getting this problem in your interview. Use tag. Now this will give you an edge. Okay, this will reduce your time of thinking over something else, right? I told you, okay, Gaurav, when you go into the interview, use use hash maps or use priority queues, use heaps. Okay, now you got the question. Okay, you know that. Okay, I have to use heaps. Now let's think about how to use a heap. Now this first thing is clear. Rather than thinking here and there, that will take time, right? It's all about reducing time. Competitive programming is all about efficiency and how to come up with a problem, how to come up with a solution in much less time, because the interviewer will not be there all day for you. He will just give you 30 minutes. If you solved it, well and good. If you didn't, okay, move to the next question, or you are then he will say the interviews or something like that. Okay, so it's all about getting you a head start, giving you a head start. Okay, similarly, what I told you about earlier when I told you guys about that thing, right? How to use stacks. Now, how to use heaps. In the next lecture, how we will use hash maps, arrays, and these things. Okay, heaps. Okay, all of these things will be covered, and next lecture is going to be very important. Okay, also for the next lecture, I want you guys to have some idea over comparator. Okay, right now I only used what min heaps. Okay, that is by default case of what priority queue, that it will use min heap. Now what if we have to use max heap? So get an idea over that. So the next lecture will be much more, you will be it will be easy for you to understand that thing. Okay, when I use comparator. Okay, go through it and solve these questions. Go through this session again and please guys cover all the sessions that I have given you already, that I have taken already. Okay, so that you will get a flow and you will be ready to go into an interview, and all those questions are very important. It's not that something. So again, here I have to give you an intuition that we use sorting and then we used what? Heaps. So again, I could have directly gone on to the heaps and showed you, okay, this is the thing that you do and that's it. But the intuition will not be there. Okay, so it's all about getting an intuition and how to approach a problem. So that's it. Okay guys, so you have to, and in this question that is shown on the screen, you have to, once you edit something in the temp, you again have to add that into the heap. Okay guys, so that that row size will be there. Okay, web design course are available, great learning. Yes, there are courses available on web designing. Okay, just go through the academy, register in it, and see all the courses will be there. Okay guys, so that's it from today's session. if any one of you have any confusion or anything that you want me to, that you want from me in the next session, or anything from the previous lectures that you didn't understood, please write, please say, or we will conclude this session. Okay guys? Okay, great guys. Okay guys, so in the next session, be prepared and solve all the problems. See the previous previous 3 lectures, go through them, implement them. Okay, so for implementing these, you can use any ID: Geeks for Geeks, Lead Code, Hacker Rank, Hacker Earth, any ID. Okay, so for these problems, just pick up the problem. That is, the slide deck will be shared with you. Just pick up the problem, put it anywhere. Put it in Geeks for Geeks, put it on Lead Code. I have seen some comments over the videos that how we will implement this, where we will implement this. You just have to go to any website. Geeks for Geeks is there. Lead Code is, Hacker Rank, Hacker Earth. Okay, all of these will contain these problems, will have these problems. So go through it and also check the complexity of these problems. Okay, you see some of them are hard, some of them are medium, some of them are easy problems. So go through it. Okay guys, great. So thank you so much guys. Thanks a lot.